Good morning and welcome to today's Solving Puzzles with Python. Let's have a look at today's puzzle. So, question 15. Can you demonstrate how to encrypt text with a password? Well, let's head off to colabresearch.google.com and see if we can. So here we are in Colab and we have a simple for loop. Now this for loop prints the values from 0 to 100. And alongside that it'll print out the character that's represented by the value. So it's a bit gobbledygook at the beginning, but when you get on to character number 38, 39, 40, onwards, you start getting the things you recognise from the keyboard. 48 onwards is the numbers on the keyboard, some values there, and here we have capital letters. And just underneath you can see we're starting to get the lowercase letters. In fact, if we change this to say 200 and run it again, there you go, you can see that after 100 there we go, we get the remainder of the lowercase characters, and so on and so forth. What this shows us is that the characters on a keyboard, the characters you see in Word documents and on emails and on websites, are represented in the computer by a number. This is what's commonly referred to as ASCII text, ASCII text. And that ensures that the value you have for a capital A on your machine is represented as capital A on any other machine and in any other format. Okay, let's move on a bit here. Two more code snippets. You can get the ASCII value of an individual letter. So letter, in this case, we're going to have lowercase r. And how we display that value is using the ordinator of the letter. So ord of the letter gets you the ASCII value. So here the ASCII value of R is 114. So R is encoded as 114. We can reverse that. So we can print the character value of 112. So ord of a letter will give you the ASCII value, but CHR of a ASCII value will give you the letter. So they're completely reversible. And there you are. 112 is P. We can change that to 116 and gives you a T. Now what this means is that if we have a message, today is a good day, we can loop through that message, and for every letter in the message we can print out the numerical value, the ordinator of that letter. There we are. So the capital T is 84. ODAYIS, you can do a quick check on this. 1, 2, 3, 4, 5. So the 6th character is a space, and 7, 8, and shows is the 9th character. 1, 2, 3, 4, 5. 6 is a 32. 105 and 32. So yeah, that looks like it could possibly be correct. You can see the spaces in there. Now what that enables us to do is that when we've got a numerical value for a letter, we can manipulate that numerical value and encrypt the message. So as our question asks us to do, we can create a password. We're just going to use a simple 3-letter password, ABC. And we can produce a crypt of our password. Okay, so the crypt is what we're going to do to our message to encrypt it. Our crypt is going to start at 0, but we could salt it. We could put a different value in there, any value at all in there, to add another layer of encryption to our encrypted text. But at the moment I've just put it as 0. Now for every letter in our password decrypt is equal to crypt plus the ordinator of the letter. So I'm taking the value of the letter and adding it to crypt. So what essentially I'm doing here is a very simple exercise. You could do something much more complicated, but all I am doing is taking the value of A, adding it to crypt, getting the value of B, also adding that to crypt, C, adding it to crypt. And so we've got the values of A, B and C all added together, and that gives us the crypt value which we're going to encrypt our message with. If there was a salted value in here, then that could be included as well. So you could do a much more complicated mathematical process, but I am simply adding the values of the three letters together to give us our crypt. But let's have a look at this running anyway. So run this. And there we are. We're printing out crypt, so the value of crypt starts with 97, which is A. Then as B gets added to it, it goes up to 195, and as C gets added to it, it goes to 294. So let's apply this crypt to our message. Here we are repeating the code which creates the crypt. I've just commented out the print value, and I've added the message in here. And for every letter in the message, print the ordinator of that letter plus the crypt. So it's going to get the ordinator of every letter in the message and apply the crypt to it. It's going to add the crypt to it. Let's see that run. And there we go. So that is our encrypted message, which looks a lot different to the unencrypted message here, which is just the ordinate values. So yeah, we have encrypted our message. It's a simple encryption, but we have done it as per the question. Now we need to decrypt it as well. So let's go on another stage. So for decrypting purposes and for storage purposes, because you might want to save these encrypted values in a text file or some other medium, even if it is not there for storage purposes, it might be an intermediate stage of your program. It might be the save points in a program, for example, or the health values, and you don't want it to be stored in plain text anywhere. You can encrypt it, store it in a list and save it, and if people stumble across it or try and hack your game, it'll make it all that more difficult. So what we are doing here is creating an empty list here called new message. So our encrypted message is going to be stored in a list. The rest, we've done that crypt, 4-letter in the password, that's doing the encryption, that's applying the encryption. This is a new bit here for each letter in the message. Append that letter to the empty list. So as we encrypt an individual letter, it is being put into the list. And here we're printing out the list at the end. This is a good one to keep and remember. Instead of having to scroll through it, we can or iterate through the entire list to print out the values. We can print it out in one line just by using the map function here. So this will give us the encrypted message again, and then print it out in a list, which is a lot more manageable than in the previous format when it just prints out each letter onto the screen. This is then something you can manipulate and store. So let's just run that here. There we go. We got the square brackets. We have our entire message stored in a list. This will enable us to iterate through it, to decrypt it, or indeed give us a single data structure which we can pass throughout our program or save into a file. So here is the last part of our program. Decrypt the message. For every item in our list containing the encrypted message called new message, for every item in the list, decrypt it by taking the item in the list, taking the next item in the list, getting the integer value of it, or making sure it's an integer value, taking the crypt off it, minusing the crypt because we encrypted it by adding the crypt on, so by taking the crypt off it'll put it back to its original value, and then turning it back from a numerical value from the alternator, from the ASCII value, back into a character. So the decrypt variable contains the character that is gotten by getting the item value and removing the crypt from it, and then printing it out. All going well, if we run this code, we should get our decrypted message. Today is a good day. There we are, exactly as the original message was, but it's gone through the encrypted process. That's it, we've answered our question, and again, using no special software, no installed software, we're running it in the browser, and just using skills and knowledge. I'll see you next time on Solving Puzzles with Python.